All right, we're starting week 7 here in geometry. We're going to be talking about polygons and something called the interior angle sum theory. We've already seen one variation of that theory when we were talking about triangles. In case of triangles, it just means that all the angles on the inside of the triangle have to total to 180, or it's not a triangle. Might be some other shape, might not even be any shape. It might not close. So now with polygons, we're talking about many-sided shapes. And we get into this sort of graphic display here, if you will, of all the different, well, it's not all, but it's many of the different types of the most common shapes that we work with. And the way that this material breaks these shapes down is in terms of how many triangles fit into the particular shape, because that's how you determine how many degrees in total there are for the interior angles of a particular shape. So if you look at the triangle, you've got 3 sides, you got 1 triangle, and we already know from the previous unit that the total of the interior angles of a triangle is 180 degrees. Now, one thing I will say, if you haven't done the test on triangles yet, be sure you go back and look at the exterior angle sum theory for triangles also, because a lot of people that I've seen that have done that test are answering questions about the exterior angles as if it were an interior angle. It's not the same deal. And you'll see that more as we get into this. So those exterior angles do not total 180 degrees. The interior angles of any triangle, they'll total 180. So if you were to fill in this graphic display, you'd have 3 sides, 1 triangle, 180. Go to the next one, quadrilateral. Now we got 4 sides, 2 triangles. Okay, 2 triangles gives you 360 degrees, which makes sense. This particular quadrilateral looks like it's a rectangle. So you got 4 90-degree angles in that rectangle. Makes perfect sense if that is the case. Even if it's a parallelogram or some other shape, it's 4-sided, it's still going to have, you're still going to be able to split it into 2 triangles, each of which the total is 180 degrees. So your interior angles of any quadrilateral are going to be 360. Do you see a pattern starting to develop here? 3 sides, 1 triangle, 180, 4 sides, 2 triangles, 360. Pentagon, 5 sides, 3 triangles. So how much is our sum going to be for the interior angles of that pentagon? Since we have 3 triangles, 3 times 180, it's 540. Yep. 18 times 3 is 54. Throw a 0 on the end, 540. So every time we increase the number of sides, we're also increasing the number of triangles, which means we increase by 180 according to the number of triangles inside any of these shapes. What you're going to see here in a minute is this actually creates a formula that we can use to figure out the sum of the interior angles of any side, any shape with any number of sides. And I don't know if you've ever thought about this before, but the more sides you add to a shape, the closer and closer and closer the shape starts to look like a circle. Because, well, if you tried to draw these out, hexagon, 6-sided, okay, 6 sides, 4 triangles, 640. Heptagon, 7 sides. Octagon, 8 sides. Nonagon, that's a weird one, 9 sides. Decagon, 10 sides. More and more sides you put into a shape, the smaller each particular side is going to be, the more and more it's going to resemble getting closer and closer to the shape of a circle. We'll never quite totally get there, because you can put any number of sides in a polygon that you want. In fact, that's what sometimes I think architects like to do that when they're designing buildings, see how many different kind of shapes they can include. So if we were to fill in that graphic, so here's the filled in version of that table. The thing to pay close attention to here is look at the difference between these two columns, the number of sides and the number of triangles. Every one of these has a difference of 2. And the number of triangles times 180 is what gives you the sum, the total number of interior degrees. And it may seem kind of crazy that you would have, and for a decagon, you would have 1,440 degrees of angles then inside that particular shape that's got 10 sides. But that's just the nature of the beast. So when you have that many, how many degrees would one angle inside that decagon be? We got 10 sides, means we got 10 angles. If the total number of degrees is 1,440, how much is one of those angles? Well, you got 10. So just lop the 0 off. 144 degrees. Look back at the quadrilateral. 4 sides, 4 angles. That one looks like 4 90-degree angles. Now, the thing to beware of, what I'm talking about with that decagon, when you divide this 1440 down here, which is the total interior angles in degrees by the number of sides, what that is referring to is something called a regular decagon. A regular polygon means all the sides are the same length, all the angles are the same size. So you can take any one of these sums out here in this final column, divide it by the number of sides in the third column, and come up with the degree measure of each angle, each interior angle of any of these shapes, if it's a regular shape. And the word regular has to be part of the definition. Because you can make a 10-sided shape easily that does not have all the same length sides. You can make any of these shapes that are not regular because they have different side lengths. Anybody have questions about that so far? Now, the different side lengths does not change the fact that, let's say this decagon, if it's not a regular decagon, each angle in the inside is going to be a little bit different, but it still totals 1,440 degrees because of this formula. The sum of the interior angles is, you discover the sum by using this calculation. N minus 2, that quantity, or what does N stand for? N represents the number of sides of a polygon. That's why I pointed out the difference between these two columns here. Difference is 2, difference is 2. Every one of these has a difference of 2. Number of sides minus 2 equals whatever, times 180 equals your total interior angles.
Is that a minus sign or a dot?
It's minus. It's the sum of the quantity N minus 2, that quantity in parentheses, and the sides, the number of sides, just like in this chart. Number of sides is in this column, minus 2 in this column, times 180.
So it's times 180.
Times 180. That's how every one of these calculations has been done in this column. Number of sides, take away 2 times 180. Number of sides, take away 2 times 180. If you have a 20-sided shape, a 20-agon, it's 20 minus 2, which is 18 times 180. That's the sum of the interior angles. Now, here's what I was talking about a minute ago. If we need to know what one of those interior angles measures in a regular polygon, here's the definition of a regular polygon. All the sides are equal. If all the sides are equal, the next part of this is all the angles are equal. So once you've figured out the total number of degrees of the interior angles, which is S, that's your sum, then you just divide it by the number of sides. That's what I was trying to get you to focus on up here when I was asking you about this decagon. 1440 divided by 10 equals 144 degrees. I picked that one because dividing by 10 is easy. You just move the decimal over to the left one spot. Hopefully you guys all know that. You should. That's easy division. So these are things you absolutely are going to need to have in your notes to be able to do this unit. And you'll see that on the next page. So 4 examples to start with. Find the sum of the interior angles of a 15-agon. Find the sum of the interior angles of a 21-agon. What is the measure of each interior angle of a regular pentagon? What is the measure of each interior angle of a regular 18-agon? The first 2 problems are the same. And you solve them the same way. Our formula is number of sides minus 2 times 180. So we have a 15-agon for one problem, 21-agon for the other. Probably need to use a calculator. So all you do, the 15 here and the 21, that represents the number of sides in those shapes. 15 sides here, 21 sides here. So it's an easy substitution. 15 minus 2 times 180. So what's 13 times 180?
354.
No, I don't think so.
Hold on.
2,340. So that's the sum of interior angles for that 15-sided shape. Minus 2 is 13. You take the number of sides, subtract 2 in that quantity, multiply that number by 180. So I'm going to pause this for a second. I want you guys to go ahead and figure out how many degrees are in this 21-agon interior angle sum. Whoops. Sorry. So we got 19 minus 2. Whoops. Nope. I'm getting ahead of myself. 21 minus 2 times 180. It's 19 times 180. And you guys got 3,420. Great. Now, for that second example, if we're going to say that is a regular 21-agon, how much is each angle in that shape going to measure? That's where the second formula comes in, where now we're going to take our sum, divide it by the number of sides. So we already know, we just figured out that the total angle measurement is 3,420. We started off knowing we got 21 sides. So if we split that 3,420 among all those sides, 3,420 divided by 21, that's a weird number. But that's what it is, 162.9. So each angle is approximately 163 degrees. They're all going to be exactly the same if it's a regular 21-agon. And so these two formulas you're going to see again and again. And right away in this next example, the next set of problems, 3 and 4, you have to use both of them. What's the measure of each interior angle of a regular pentagon? Okay, well, don't you need to know the total degrees first? Yeah. So you got to do both of those calculations for problems like 3 and 4. So from the chart, we already know that a pentagon's interior angles total 540 degrees. Pentagon, that's 5-sided. So 540 divided by 5. Each angle in the interior of a regular pentagon is 108 degrees. Are you noticing anything about the size of these shapes? The more and more sides they have, the size of the angles, the more and more sides these shapes have. They're opening up more and more and more. That 21 what did we say? 162 or something like that. Pentagon, 108 degrees. So these shapes, that's what I was talking about before, start to open out, and every angle opens out more and more and more to be obtuse. You get closer and closer to having a circle once you get them all together. If you've ever tried to draw an 18-agon or a 21-agon, let's try that. Yeah, 162.9. So if I'm trying to draw a 21-agon, 1, 2, 3, I'm not going to be able to do a very good job of it, but 4, 5, 6, 7, 8, 9, 10, 11. I'm not even sure I'm going to get to 21. 12, 13, 14, 15, 16, 17, 18, 19, 20. Not a very good example, but I think you get the idea. If that's, let's say I got actually 19 sides in there, it kind of looks like a circle. But every one of these angles is a huge obtuse angle, right? That's the only way that this can become a shape. Questions so far on either of those two formulas?
Can you run out the number 3? Can we do number 3?
Sure, I just talked through it. You needed me to write it out?
Yeah.
Okay, so formula for the total interior angles, that's where we start. All right, the Pentagon, 5 sides, just like the Pentagon in Washington, D.C. You know, if you connect all the lines inside of a 5-pointed star, you get a pentagon. You guys notice that? Or did you know that? Pentagon, right in the middle. The one I drew there is not a regular pentagon, but that doesn't change the amount of interior angle degrees. So all I got to do is go back to the formula. 5 minus 2 times 180. 3 times 180. So the total is 540. That was, I pulled it off the table from the completed table before. So how much does each side or each angle measure? That's where you use the other formula. The sum divided by n, which is our number of sides. So 540 divided by 5. So each angle is 108 degrees. So we're not talking about side lengths here. For the most part, we don't really even care about side lengths of these kind of polygon shapes. We're just trying to figure out what angle measures we got. Questions, anybody?
Oh, I'm good.
All right. Problem number 4 would be exactly alike. Going to do the same process. You got to find the total number of degrees first in that regular 18-agon, and then divide that number by the number of sides. Now, the next piece of this talks about exterior angles. Very important. Exterior angles are always supplementary to their adjacent interior angles. Supplementary. What does that mean? How many degrees do two angles that are supplementary total? This goes back to one of our earlier definitions. Everybody should know this by now. How many degrees are in supplementary angles?
$180.
180. Everybody should have been jumping on that. That's not a hard question, guys. Come on. 180 degrees from supplementary angles. So once you've figured out, like in our regular polygon example, our regular polygon, that's what each interior, pentagon. So try this again. See if I can draw a regular pentagon. Pentagons kind of look like home base in baseball. That's pretty close. So if each one of these interior angles equals 180, where do you find, see that you got interior angles here, you got 5 of them, right? Each one of these is 108. How do you know about the exterior angles? Well, go back to our triangle example. Isn't this the exterior angle from a triangle where I have that X labeled? This is what I talked about earlier with that from the triangle unit. If you guys haven't done that test yet, I would encourage you to go back and look at this exterior angle sum theory, because for triangles, this angle out here equals the total of these two angles. But combined with this one, the one it's adjacent to, it's supplementary. Same thing happens with any exterior angle from any polygon. If I continue, if I extend any of these lines, I can create those exterior angles. Extend every one of those sides, I have the exterior angles. That's what they're talking about, exterior angles. So these two here together are supplementary. These two here are supplementary. It's got to be in a pair to be supplementary. So once you start extending those sides beyond the limits of the shape itself, then you can start identifying those exterior angles. So for a pentagon, a regular pentagon, all the exterior angles are going to be the same because all the interior angles are the same. So supplementary just means you subtract from 180. So every one of those exterior angles on a regular pentagon is going to be 72 degrees. Because 72 and 108 equals 180. So the examples that follow this particular explanation are not regular shapes. How can you tell that they are not regular?
The interior isn't the same. They're not the same number.
Exactly. The interior angles are each different. Remember, for the definition to fit for a regular polygon, all the angles have to be the same size. So they're not. No big deal. If we're still trying to figure out what the exterior angles are and we have to come up with a sum of the exterior angles, you're going to see something that's interesting. And with these arrows here, like in this first example, you know it's a triangle and that all these interior angles are going to total to 180. But now, because we've also added the fact that exterior angles are supplementary, what are those exterior angles in this particular triangle? I'm going to give you a minute to figure out what the supplementary angles are here that are exterior to that triangle. Oops. All right. Good job identifying those exterior angles here for this triangle, Jonathan. 79 and 101 together equal 180. There's supplementary. This one is 61. 119 is our exterior angle that makes that supplementary. This is the easiest one here. This 40 degree goes with 140 degrees. So when you add those three together, you get 360 degrees. And no matter what shape you're talking about, the sum, this is the easiest part of this whole lesson. But don't get it confused with the interior angles. Okay, we start off talking about a formula to find the sum of the interior angles. This is not interior angles. The sum, and there's no formula, the sum of the exterior angles is always 360 degrees. I don't care how many sides the polygon has. It's always 360. You have to start off by figuring out the supplementary angles that are on the exterior of the shape and then adding those together. That's what we did on this triangle. So you'd be looking for a supplementary to 124, supplementary to 76 on this quadrilateral, supplementary to 89, supplementary to 71. Those supplementary amounts, when you add them all together, are going to equal 360. I know they say never say always, but it is true for exterior angle sums. And there's the 4 examples that they're showing there: triangle, quadrilateral, pentagon, hexagon. They just went through 3, 4, 5, and 6 sides, but it doesn't matter if it could have 100 sides. The sum of the exterior angles is still going to be 360 degrees. And And your exterior angles are always going to be supplementary to the adjacent interior angle. Just extend the line of the shape beyond the shape itself, and you'll see what pair of angles goes together, interior and exterior. So the conclusion right there, the sum of the exterior angles of any polygon is 360 degrees. Does not matter how many sides it has, how many angles it has. And you notice we're not talking about regular polygons here. We're not talking about a regular triangle. We're not talking about regular quadrilaterals. Regular for us means the angles are the same and the sides are the same. Now, the next couple of problems on here for practice, those first four only talk about regular shapes, a regular hexagon, a regular 24gon. Number 7, if the exterior angle of a regular polygon measures 12 degrees, how many sides does the polygon have? So with these exterior angles practice problems, now they're starting to force you to think about what the interior angles are also. Because what do you need to know to solve number 5?
What the interior angles are?
Yeah. So on that one, you're going to go back to that n-2 quantity times 180 calculation. That's going to give you the interior angles. Then you're going to divide by the number of sides. So a hexagon, 4 times 180, 720. So it's got 6 sides. We'll divide that by 720 divided by 6. So each interior angle is 120 degrees, which means each exterior angle has to be 60. You're probably wondering how I came up with that. Hexagon. Hexagon is 6 sides. Times 180. Okay. N is the number of sides times 180. 4 times 180 is 720. And it's a regular hexagon. So each interior angle equals my sum divided by the number of sides. Okay, sum 720. I got 6 sides in a hexagon. Each interior angle is 120 degrees. Now, how did I get 60? Well, I'm going back to use that definition of the exterior angle. Exterior angle supplementary with the adjacent interior angle. Okay, so 180 minus 120 is 60. For the regular shapes, that's easy because they're all of them are going to be the same. And again, the exterior angles are all going to total 360 because I'm going to have, for a hexagon, I got 6 exterior angles. Each one of them is 60 degrees. 60 times 6 is 360. Problem number 6 is exactly like that. How would you solve number 7?
Just say it's a polygon.
It says it's a regular polygon. How does knowing what the exterior angle of a regular polygon, how does knowing that help us?
It's how many points it's got.
We're talking about degrees here. We're talking about angle measurements. Can we use this definition when all we know is that the exterior angle is 12 degrees? Can we use that definition to find the interior angle measurement? The answer is yes, we can. Because the definition tells us that the exterior angles are always supplementary to their adjacent interior angle. So for this polygon in number 7, our exterior angle is 12 degrees. So what is the interior angle that makes it supplementary? What's 180 minus 12?
178.
Well, I'd take 168.
Oh. I'm not finishing my problems.
It's all right. You're trying. I don't hear anybody else volunteering anything, so I appreciate that, Jonathan. So regular polygon, now we know the interior angle measurement, so that might help us. What do we know about all the exterior angles of any regular polygon? What's the total degree measurement? Exterior angles of any polygon.
360.
Yep. So a regular polygon where every angle on the exterior is 12 degrees. I didn't spell supplementary right. It's supposed to be an E in there. So remember, our sum, exterior sum, divided by number of sides is going to give us the exterior angle. And this question is asking us, how many sides does this polygon have? Okay. I got 360 degrees and my exterior angles. I don't know how many sides, but if I did, I would get 12 degrees. Can we solve that equation? Somebody other than Jonathan? Do I have a solvable equation here? Yes or no? That's all I'm waiting for. Naturally, I do have a solvable equation here. All I got to do is multiply both sides by n to get rid of that fraction. (360) equals 12n. I'm going to do the opposite, divide both sides by 12. I think this has 30 sides. See if I'm right. Yep. So the answer to that problem is that regular polygon has 30 sides. And all I did was take the number of the exterior angles, the sum, and divide it by one of those. If it's a regular shape, all the angles are the same size. So you're going to see a lot of those kind of problems in here, and you'll see those kind of problems on the test. Whoever filled this out used X instead of N. I used N because that generally is the letter it's used to refer to the number of. X is fine though, it's an easy variable. So top of the next page has got a series of blanks here for formulas. Can somebody tell me the sum of the interior angles of a polygon? Morning. Every one of these formulas is going to come into play in this unit. So you need to have all 5 of these in your notes. The problem that I just did uses this last one. You take 360, that's the exterior angle measurement total, divide by the number of exterior angles, and that's going to give you the number of sides. Excuse me, exterior angle measurement. Series of practice questions right after this. And you can see that each one of these asks for a slightly different version or a variation of some of these formulas. First 2 ask about interior angles. Then The second two ask you about each interior angle. And again, it's using that, it's dropping that keyword regular into the equation, into the problem. Regular meaning they're going to be all the same. So those would be good practice problems for y'all to do. On the next page, there's other problems with that are similar, and it asks you to figure out, is it this starting to add some little algebra in here too, because now you've got some unknowns. Problem 14, for instance, has got some expressions in there that represent the angle measurements. And now you got to solve for x. $15, you got to, not only do you have to solve for x, but now you got to find the measurement of an angle. So let's start with number 12. How do you find the value of x on that four-sided shape? Don't you need to start with the total of the interior angles? So what's the sum of the interior angles of a four-sided shape? And ladies and gentlemen, you don't have to do this calculation every time there's a problem. That's why we started with this table. This is one of those things that, you know, you guys, I've been asking you repeatedly, are you using your notes? Are you using your notes? This is a perfect example of what I mean. I'm not asking you to memorize this. Nobody can memorize all this. Well, maybe some people can. You got a photographic memory? Great. I don't. I can't do it. I don't even know anybody that can. But I'm sure there are people that can do that. So when you're working one of these problems, have this table next to you. What's the total number of, what's the sum of the interior angles of a quadrilateral? Well, just go to the table right here. It's a four-sided shape. It's 360 degrees. Easy. Use the reference material that you're given. So in this example number 12, find the value of x. I know that the total number of interior angle degrees is 360. So what would I do to find x? I got three angles that I know. 110 plus 79 plus 55, that's 244. So then all I got to do is subtract 244 from 360, and I know that x is 116. So virtually every one of these kind of problems is going to come back to this interior angle sum theory. So how many sides are in this shape in problem number 13? 1, 2, 3, 4, 5,
7.
6, 7. Okay. So the interior angle sum theory, and thank you for responding. I don't know who that was, but it was a different voice. So I appreciate that. That's what I'm looking for. So 7 minus 2 is 5. 5 times 180. The total number of degrees that are in that shape's interior, 900 degrees. Because it's a heptagon. It's a 7-sided shape. It's not a regular one because none of those angle measurements are the same. Then you just do exactly what I did on the other one. Add up the ones that you know. What are you going to put in here for this, the one that's got the square in the corner? You can't leave it out. You better put 90 in there. as part of your calculations. That's a right angle. So put 90 in there.
Okay, so you'd be adding all of those and then adding 90 as well.
Yeah, that's one of the angles. You know that this one down here in the corner is 90 degrees.
Sorry, Jay, I'm trying to pay attention, but it's so hard. It's confusing. So bear with me.
At least you're saying something. I appreciate that, Elvia. Thank you. Let me see if I can clarify this here. I need to do a little quick. Okay, so to catch
Just
up,
kidding. It's 94.
there we go. That sounds like a better number. Elvia has gone ahead and added up the total, including this 90-degree angle down here. We got 1, 2, 3, 4, 5, 6, 7 sides. So our interior angle sum. Interior angle sum. It's a simple calculation, right?
Right.
And minus 2 times 180. That's how she got 900. So 7 minus 2 times 180. So our total interior angles is degrees is 900. So we know all of the angles except for this one where X is. So really, it's 90 plus 148 plus 140 plus 136 plus 142 plus 150 plus X equals 900. Should have 7 numbers there. 1, 2, 3, 4, 5, 6, 7. Yep. And how much did you say you got when you added up those up? 800 and something?
806.
Okay. So at this point, it's just equation solving. You got a bunch of numbers that you can add together. 806 plus X equals 900. Subtract the 806 from both sides, right? I mean, that's how we isolate a variable in a one variable equation. And so you know that that last missing angle is 94 degrees. But it all starts with counting the number of sides and using that interior angle sum theory, using that one formula. It's a good job, Elvia. Thank you. That wasn't so bad, was it?
No.
No, I didn't think so. See, I got to get back to my other sheet here. Okay. So all these kind of problems are going to end up like that. You know, they're going to try to make it look more complicated by throwing an algebraic expression in here like 8x minus 1. No big deal. What do you think number 16 means? That looks like a regular something, right? How come there's only one angle measurement in there?
They're all the same.
They're all the same, right? And you know by those tick marks too that all the sides are the same, right? That's the congruency symbol. So that actually makes this problem easier because once you count the sides up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 10 sides. How many interior angles? In total was our 10-sided shape, 1440. So that one's going to be 1440 divided by 10x plus 4. That's how you're going to come up with one angle measurement. What would you do with a problem like number 17? We don't have any interior angle measures, but I don't think it makes any difference on this one, because these are all exterior angles. What are they going to total to? Go back to your definition.
360.
360, right? This is another example of why we got to keep these definitions handy. Yep, wrong page. Here we go. The sum of the exterior angles of any polygon is 360 degrees. So we're really only talking about a couple of different theories in a sense, a couple of different formulas that work for all these different problems. We're just about out of time. So questions, anybody? All right, and we're going to have to stop there because then we're going to get into these properties of different types of shapes, and that's more note taking and a little bit more complexity.
I'm confused about the algebraic equations, number 14, I think.
Yeah, this one?
Yeah.
Okay.
So would you say you do just, because I just put them all in order and then combine like terms and just did it that way?
Yeah, exactly.
So you do that and you get your equation. I got 26x plus 278 equals, is it equals 180?
No. How many sides are in this shape? 1, 2, 3, 4, 5, 6. So that's a hexagon. The interior angle total for a hexagon is not 180. 720.
So that's where I got mixed up.
Yeah. We still need to know what the total of the interior angle degrees are. Because if you've added all of these interior angle descriptions up and did what you said, combine like terms, that's going to allow you to solve for X, but all that's got to equal 720. In the same way that we added all these up in number 13 that equaled 900 because it's a heptagon. You got to have that interior angle total, that sum, to work with on the other side of your equation. So try some of these other problems over the next day or two. You know, if you get stuck on something, send me a picture, send me a photo of it. I don't have anything scheduled yet with anybody for tomorrow morning. So if you need extra help, then text me and let me know.
Okay. One more question.
Go ahead.
So is the answer to number 14 x equals 17?
That sounds reasonable. Yep, you got it.
Nope.
You're on it, Jonathan. Way to go.
Until the test, you know.
Well, keep your notes next to you.
I don't think it's the notes. I think it's just me. It's definitely just me because like I write everything down. I have paper and pencil every day. So I don't know.
Trust your answers. Take the first
I
one.
take pictures. I take pictures of everything. So.
Well, Just got to get through. We got a couple more weeks, right?
Just gotta
You're-
try to pass it.
You guys are close to the finish line here. Don't give up now.
I'm not
Okay.
giving up twice.
No more of that. Okay, guys. See everybody on Thursday, okay?